Mohammed, for setting that up. My talk is going to be kind of similar, but instead of using the Atom database, using the tax assessor database that we had for Seaside. And then in particular, comparing these two databases and doing damage estimates and economic losses. So a little bit of background on the tax lot data that we've been using. So this is in NCORE. There's 4,679 buildings or points in this database. And this was developed by Hungsoo Park originally, and was largely collected from Clatsop County tax assessor data with some Google Street View spot checking and then a field survey too. On the NSI side, so this was, I guess, I believe publicly released last November. So I pulled this down from their website. And for the same geographic region, there's 4,651 points, so pretty comparable there. I believe they have a public and private version, so using the publicly available version for this, where they kind of don't provide as many attributes in the data, or some of the data is provides medians and stuff instead of specific information. And then this data, my understanding is also that it comes from a variety of different sources. And you can see in these two map and sets some differences in the spatial variation, as well as with NSI, some points that are kind of located in places that may not be accurate. And so with these two data sets, have two primary questions really interested in looking at. So the first one is just like out of the box, how do these two data sets compare as input to NCORE? So just comparing the two data sets, looking at the tax lot data and then the NSI data. And then the second question here is, what if we run these two data sets both through NCORE, and how does the output compare? So after we run NCORE on the tax lot data, how does it look compared to running NCORE on the NSI data? So kind of the first quick snapshot of looking at the input side of things. Wanted to first look at the number of points. So this left-hand plot shows the NSI data, and the right-hand plot shows the tax lot data. And then each polygon here is color-coded according to the number of points that are in that polygon. So purple being 0 points, and then yellow being more than 3 points. If you can see how these two differ at this parcel level here. Kind of taking these two things, looking at them on top of each other, also computed this, or made this map over here on the right of the percent difference. So in this case, any polygon or parcel that's red means there's more NSI points in that polygon, compared to blue is the opposite. So there's more tax lot points in that polygon compared to the NSI. We see, and then gray here is they're even. So you kind of see where pieces are different and where they're similar here. So that's at this parcel level, but one thing we're really also interested in looking at is how does the NSI data compare to the tax lot data at this really fine spatial scale, so the parcel level, but then also aggregating things up ultimately to the community level. So we have the same percent difference plot with things aggregated at the parcel level. And then we aggregate things up to the block level, and then the block group level, and then the track level. And so you can see how these two data sets differ at these different spatial scales. So at the parcel level, you can see there's some gray in here with some like red and blue spots kind of sprinkled without. The block level, there's a lot of red here where there's more NSI points, with some kind of pieces along the coast here where there's more tax lot points than NSI there. The block group things start to get kind of gray here, so pretty good. And then the track level things are pretty comparable, kind of around plus minus 10% or so in this difference. We also wanted to kind of think about putting like numbers on these. So looking at this block one in particular, we can make these relationship plots where we have on the x-axis tax lot, and then the y-axis NSI. And this is at the block level, and this plot shows the number of points in a block. So for example, this point down here, maybe there's 80 or so tax lot points in a single block, but that same block also contains maybe 15 or 20 NSI points. And then we just compute some statistics on these, so it's correlation coefficient, fit a line of best fit here, and compute the slope, and then the RMSE error for that. And again, this is at the block level, but then we also wanted to think about these different spatial scales. So in this case, we have P here is parcel, block group, and then track. And then each column here is a different attribute. So before all looking at this number of points in a parcel block group and track, but then the NSI and our tax lot data, we have dollar value, year built, square footage, and the number of stories. So we compare all these different attributes across all these different spatial scales. And this top row is the correlation coefficient, then that slope from the regression, and then the RMSE. So we can start to see kind of at what point these data sets become comparable, and especially interesting on the RMSE, how that really decreases sharply once you get around the block group level and track level here. So that's all on the input side, but then also really interested in thinking about what if we take our tax lot data, run it through NCore, and then take our NSI data, also run that through NCore. How do the damages look on the output side of things? So this plot, again, kind of sticking with the same idea of these relationship plots with the tax lot on the x-axis, NSI on the y-axis. In this case, computing this expected damage state from NCore. And this is, so expected damage state for this 500-year earthquake and tsunami. So CM is cumulative damage here. And again, aggregating things at the block level here. You can see there's pretty good comparison when running this particular event and then aggregating things here at this kind of second spatial scale. And these plots too, these kind of red points indicate there's a block that has, these ones over here are blocks that have NSI points, but no tax lot points. And there's similar, I guess the opposite side of that down here on the x-axis, where there's some blocks that have tax lot points, but no NSI points. And so we had that last plot was this one here, but for Seaside, we have 7 different recurrence intervals. So we can run NCore across all these different recurrence intervals. So 100-year out to 10,000 year. And then over here on the right is the spatial scale. So the top row is that parcel level. So comparing at the parcel level, how do these compare? The block level and the block group, and then the track level. And again, keeping tax lot on the x-axis and NSI on the y-axis here. And so you can see, for example, at the 500-year recurrence interval, at the parcel level, kind of that spread of data, and then kind of it gets a little bit tighter once you increase the spatial scale we're aggregating things at. Then also looking across the recurrence intervals here, can see for the 10,000-year event, how everything kind of gets clustered up in that top right corner, everything gets wiped out. For the 100-year event, things are kind of clustered down in that bottom left corner where there's not much damage. There's a lot of variation in these mid-recurrence intervals here. The last thing we wanted to look at, or I'm showing here, is not just building damage, but also economic risk. So in this case, we take NCore, we run our building damage analysis, compute the mean damage, and then using NCore also do economic losses. And then accounting for inflation from 2012 to 2022 to get the dollar values kind of on the same level here. So this plot shows this first one is earthquake, and then tsunami, and then cumulative economic risk. And economic risk are the direct losses divided by the recurrence interval. So it's annualized economic losses here. And then we have each plot goes from the 100-year recurrence interval up to the 10,000-year recurrence interval. And so it's interesting to see how, in this case for the cumulative, for example, things are pretty comparable again at this low recurrence interval where you don't have much damage. At the high recurrence interval, also pretty comparable where everything gets completely wiped out. And then for this mid recurrence interval here, there's a lot more variation in how these the output looks on this economic risk piece. And there's also like the high risk events here, so kind of interest where it's both high losses and high probability of occurring. So quick kind of summary here of this stuff. As kind of input to NCore, the number of just buildings between these data sets are pretty similar. And there's the largest error at the parcel level, and then smallest error at this track level for many of these attributes. And then on the output side, again, kind of see that same like spatial difference where we have large error at the parcel level, small error at the track level. And then for the economic risk, a lot of the largest difference between these is for these high risk events where we have both large losses and high probabilities of occurring. And that's all I have. So I'll, I guess, stop sharing my screen and take questions.